Welcome to Southwest Flight ACC 440 with service to FSA. For those of you just joining us, that's Financial Statement Analytics.
The crew serving you today is Andrew, Tabitha, and Adam. Please fasten your seatbelts. We are expecting some turbulence today.
Thank you for choosing Southwest Airlines and welcome aboard.
As we prepare for takeoff, we will first discuss data acquisition and cleaning. We imported pandas, numpy, and matplotlib, and then we written the massive data file that we got from Wharton Data Services. We first took a quick look at Southwest Airlines by looking at their ticker and looked at the first 10 lines. Then we filtered the data just to look at airlines. And so we used the SIC code 4512, which took the airlines from the transportation and got our data from there. Right here, you can see we just got our data from Southwest. And here's our DART info so we can see what kind of data we were working with. And right here, this is a description of the variables that we pulled from the Wharton Data Services. And then to start cleaning the data, we backfilled the variables. And so as we know that other long-term debt, capitalized lease obligations, and other investments are normally missing. So we just fill that in with 0. As you can see, this is what we did with our code right here. And then we wanted to remove and adjust some other observations. So companies that had an equity with less than 100 or negative pre-tax income, we kind of filter that out. And also we fixed the effective tax rate. So any outliers that had an effective tax rate less than 0 or greater than 50%, we cleaned it out here. So in line 2 right here, we computed the tax rate, and then right here we use a dot between to filter out any of the outliers. And then we just did a dot describe so we can see what we are working with.
Now that we've reached our cruising altitude and cleaned our data, we'll get started and talk about ROE, including DuPont and Penman. So first, in order to calculate Penman variables, we'll need to create new variables from the balance sheet, including operating assets, operating liabilities, net operating assets, non-operating obligations, non-operating assets, and net non-operating obligations. And here's where we calculate all of those. A little further down, we're also going to need to calculate new variables for the income statement, which is right here. So pre-tax NNE, NOPAT, and then net NNE, or just regular NNE. And that's where we calculate all of those variables. And then down here for our Penman ratios, we'll first need to create some lagged values of the assets and the equity, as well as lagged values of the NOA, NNO, and OA. And then we'll compute some averages. And then we'll finally be able to compute our Penman variables. And after we do that, we'll clean up some of our oddballs and our outliers. So here's where we do all of our lagged variables. And as you can see, we also made sure that we lag them only by 1 year so that we don't end up with lagged variables over multiple years. And then we check our work right here, just make sure everything looks okay. As you can see, we have some missing variables, but that's because these years are not consecutive, so that's fine. Okay. Here we finally get to calculate our Penman ratios, and that's ROE, RNOA, NOPM, NOAT, FLEB, and spread. Now that we have our Penman variables, we're going to clean them up. In cases where the average NOA, OE, and OA are less than 0, it's not meaningful, so we'll get rid of those cases. We also are not going to worry about any infinite numbers because we didn't see any from up here, so we won't worry about cleaning those up. So here's where we drop those when they're less than 0. And then down here we're just using a dot describe to make sure our data looks okay, and it does. We also we decided not to linearize because none of our variables were crazy outliers. So you can see our max, none of them are hugely different from our 99%, and the minimums are also not that much different. So we did not linearize. And then we want to look at just Southwest Airlines. So we filtered by their GB key code. And that's what this is. So it gives us all the information for Southwest, but that's not super useful and just looking at straight up numbers. So we decided to do a timeout analysis for those numbers, and we used a graph, which you can see here. So in this section, we did some further analysis just to look into net borrowers versus net investors. And there's 3 different ways we can tell this. So if NNO, pre-tax NNE, or FLEB is greater than 0, that means people are net borrowers. So here's in general for airlines, and you can see most of them are net borrowers. Then we looked at just Southwest, and Southwest is also mainly a net borrower, as you can see from their numbers. With pre-tax NNE, this also shows that most airlines are net borrowers, and Southwest is as well. That's what you can see here. And then with FLEB, again, most airlines are net borrowers. And with Southwest, they are a net borrower. However, their FLEB has been decreasing over the years, which is interesting. We decided to do a graph as well of these 3 things just for Southwest. So as you can see, it's positive for all of these values, and it's increasing for NNO, pre-tax NNE. And then as we saw earlier, FLEB is decreasing. We also want to look at ROE versus RNOA. So this is the spread for all airlines, and then most of them centered around 0, which means there's not a difference between ROAE and RONOA. We also looked at RONOA and ROE versus debt, and then we decided to look at it just for Southwest, and you can see that they're very closely correlated. Here's our correlation matrix for those, and then we also looked at FLEB, so not just debt, but FLEB. For all airlines, and that's what this is here.
All right, folks, we've reached our cruising altitude of 35,000 feet. You'll notice that the fasten seatbelt light has been turned off. Please feel free to turn on your electronic devices and roam about the cabin. Next, we're going to look at earnings quality. Here we imported pandas, numpy, and matplotlib again. Next, we pulled in our big CSV file from the awards database. What we did here is we created an accruals column so that we could be looking at accruals. And then down here we filtered, we only wanted years after 1999. This is because in the audit data that you'll see later, we only have data from 2000 forward. So we went ahead and filtered this data back here. Next we filtered just to pull in the airlines industry based on the SIC codes. We found that between 4,500 and 4,600 is where we got all of our airlines industries. Next, we created some lagged variables. We created lagged variables for assets, revenue, receivables, and ROA. We did that here using group bys and wheres in order to get those things lagged by 1 year. And then we ran a quick check just to make sure that our lag data was showing up, and it looks like it is. You can see that that very first year, 2000, is a null, which is exactly what we would expect to see using lagged variables. Okay, next we use some of those lagged variables as well as the accrual data, the accrual column we created earlier in order to create total accruals. And then 4 X variables, those include the intercept, cash sales, PP&E, and ROA. Using those 4 X variables, we'll be able to later calculate coefficients. And then here we run a dot head in order to check and see how many variables we've got. So right now we're at about 600, our lowest are around 500. Cool. Next, we remove our missing variables and windsorize our primary variables. We do this using drop NA just to make sure we selected only the variables that we created. This is because if we have this data, then we don't necessarily need to drop a whole column just because some other data point is missing. Then we decided to fill NA values with 0 using the .fillNA. We filled them with 0 rather than means. It was just a decision that we made, hoping that it would influence our outcomes as little as possible. However, there could be an argument made for filling with the means. You'll notice now in the .info we have about 579 data points. So by this point in the class, we had about 37,000. So we were already starting to recognize a bit of a limited data set. Here you can see a .describe showing those variables that we created and the maxes and mins. We noticed that we were going to need to windorize with some of these high extremes. So we went ahead and windorized using the SciPy. After windorizations, you can see down here our limits. After windorizations, you can see that a lot of those extreme values are gone. Okay, next we looked at the discretionary accruals regressions. This is where we started to determine what influenced those 4 variables, how much those 4 variables influenced our discretionary accruals. Here this is a simple regression just to make sure that we are on the right track up until now. What we're looking at here is a regression that runs how well our variables we created up here predict discretionary accruals in the airlines industry. We can see an R-squared of about 8.87 here, which is high. So this is a good sign that we're onto the right stuff. Okay. Next, we did not need to use group reg earlier when we ran that regression. However, we ran it here just to make sure that everything was ordered by SIC code and year. You can see down here in the output.head that we have 2001 and onward. We don't have any nulls. Everything is filling out how it should. We have divided by grouped by SIC code and year. Okay. Next, we renamed the variables beta 1, 2, and 3, 1, 2, 3, and 4. This is just to keep them straight from the variables we'll create a little bit further down. And then we went ahead and merged those variables that we created with our original data set. Okay. At this point, we used those predicted variables that we created earlier in order to calculate our predicted Y or our predicted discretionary accruals, and then we used that column to compare it to our actual discretionary accruals in order to calculate excess discretionary accruals, or when we were off, basically. Down here, we ran a discretionary accruals graph here. So we created a plot for each of the 7 largest airlines in our data set and tracked their discretionary accruals over time. So here you can see in the airlines industry, it appears that the use of discretionary accruals is very volatile. However, they do tend to center right around that 0 mark. Okay. Here we decided to cut back our data a little bit. We had a lot of columns leading up to here, so we just used the chop there and only kept the certain columns that we wanted. And then we ranked companies based on the amount of discretionary accruals they had. As you can see, we did this using the group by and then the .transform method. And that over here, we got our ranked discretionary accruals from 1 to 10. And then right here, we dropped any NAs. And then down here in this .describe, you can see that we have between 1 and 10, and our average is somewhere right around 5. So this is about what we would expect. We just wanted to make sure we didn't have anything higher than 10 or less than 1. Okay, I mentioned audit data earlier. This part, we're bringing in the audit data. Again, this is the data that only begins with 2000. We don't have anything before that. So we brought in that data. This basically just tells when companies have gone bankrupt or when they've had misstatements and fraud found in their accounts. We merged that data with our original data set. As you can see, we ended up with about 517 data points. Okay, and then per ranking, so that 1 to 10 I mentioned, these are the percentage of discretionary accruals. Okay, folks, we'll be experiencing some turbulence, so please remain seated and fasten your seatbelts. This is where the weakness of our data, having so few data points, really comes into play. You can see that when we ran our plots of ranked discretionary accruals predicting this fraud measure from the audit data, we don't get real pretty information. It appears that right around the middle, you can expect a little bit higher, occurrences of fraud. Again, down here with clerical errors, we see a little bit skewed toward the bottom, but again, just not a lot to go off of. Down here, we ran again medians instead of means. This is the same type of information as before, and again, we can see a pretty good range here from about -6 to +6. But now these are, don't forget, shifted. Okay, and then again down here, looking at the audit fees for companies, we would kind of have expected something like this, but just the limited data, we didn't get it. And then down here, this is based on, again, we're expecting something a little bit lower. So a little bit of turbulence, but that's all right. We knew that we were coming into this with a little bit, few data points. Down here, we ran these regressions just to see how well our predicted values were able, our variables were able to predict chances of fraud and of malpractice and playing unfairly here. And again, with limited data, we just didn't run into a whole lot. So I don't know how much we would trust these, but we went ahead and ran these anyway and were able to get some data. Okay, now on to the Beneath score.
Well, folks, looks like we've made it through the turbulence. Feel free to get up and use the restroom, but please do not form a line at the forward lavatory. Jake, really pause it and go to the bathroom if you need to. We know this is a long flight. So now we'll be talking about the Beneath score. And we pulled in some fresh data right here so that we're not getting any of the data from before. We'll need to compute some new variables, and that's those right here. And then we're also going to restrict to cases where revenue is greater than 0 and the total assets are greater than 0, so as to not affect our the M-score. So here's where we compute those variables. And then it's a lot of variables. And here's where we restrict a lot more. And then we want to create some lagged variables, and we do that here. And then we're going to look at these lagged variables just to make sure everything worked out okay. And it looks like it did. We remove some missing values. We drop those missing values just because we don't want to affect our scores later. Oh, here we go. Okay. And now we'll create the actual M-score inputs. And those are what's listed right here. So we're going to have to calculate each of those, and then we'll combine them to create our M-score. And just a reminder, an M-score that's greater than negative 1.78. So anything that's more positive than negative 1.78 means that the company could be a manipulator. So we'll get rid of our infinite values because that throws off our numbers. And then here's where we calculate each one. I won't go through each of them because it's a lot of work and we don't want to take too much time. So here's the days sales and receivable index. We do that. The gross margin index. Here's the asset quality index, the sales growth index, depreciation index, sales general and administrative expenses index, leverage index, and our last one, total accruals to total assets. Whew, okay, we made it through all that. We just want to make sure we're left with some. You'll notice we have some null values, but that's okay. And here's our entire data set. That's a lot of stuff. Okay, so down here is where we backfill those variables with 0. And we do that because we want to be conservative and we don't want to fill it in with the mean and have it affect the M-score. So we go ahead and do that. And then we sort it in preparation for our Winsorization. So that's what this is. And then we actually Winsorize all of those variables that we just created. So we get rid of any crazy outliers. And here's what we end up with. So now we're to the actual meat of it. And we get to create our M-score. So here's the equation that we'll use. Again, reminder, it has to be more positive than negative 1.78, and that means they're a manipulator. So we go ahead and calculate the M-score for all the companies. Here's just kind of an overview of the M-score. So 50% is at -2, and you can see up here where we start having our manipulators. And then we wanted to look at all of them, and we sorted them by their M-score. So this one is the airline that we found that had the highest M-score. Actually, these are the top 10 with the highest M-score. A little scary that Southwest is on there, but that's okay. We wanted to see how many times Southwest was on there, and it turns out only 2 years they've had an M-score higher than negative 1.78, so that's not too bad. And then we computed the percentiles, and we plotted them as well, so you can see our graph here. Obviously the 50th percentile, there's not much to see there, but it's more interesting to look at the higher percentiles because they're the ones that have a lot more variation and tend to be greater than negative 1.78. We also looked at a graph of the M-scores over time for the select companies that we used earlier, and that's what it looks like here. So it's a little bit crazy and all over the place, but it's interesting to see how Southwest, which is dark blue, compares to all the other companies. And that's the end of that section. 45 minutes outside of FSA. At this time, if you'll look to your left, you'll notice the Altman Mountains. Enjoy the view. We're going to get started on our credit analysis. So first we import fresh data again, just to make sure we're not getting any leftovers from some of the other stuff, and we read in that data. And then we filter again so that we're left with only airline companies. And just looking at the data, everything looks good. Because we can't access some of the word stuff directly, we use the same bankruptcy data that we used in class, so we're just pulling that in again, but filtering for only airlines. And then now we'll go ahead and start calculating our financial distress measures. So the first one, as we mentioned before, is the Altman Z-score. So there's 5 things that we'll need to calculate. These are the ratios that we'll be calculating to figure out what the Altman Z-score is. Just a reminder, a Z-score below 1.8 means it's likely that the company is headed for bankruptcy. So that's what we'll be looking for. We sort it first so we can Winsorize, and that's what we do down here. We Winsorize all of our variables, make sure nothing looks too crazy, and it doesn't. And then we actually calculate out that Z-score by using our formula from up above. Okay, and we'll talk about this a little bit later, but now we're going to calculate the probability of financial distress for all of our companies. So this one requires a lot more variables. I won't read through all of them, but here they are, and we're going to go ahead and calculate them in our stuff, in our data. So some of them we already have from the data that we pulled in up above.